This is a continuation of the first part. If you have not watched it, turn it on right now. And we are moving on to testing the performance of the video accelerator when limiting its energy consumption to 50%. Measurements are carried out on the procedure of dividing the music files into the components of the drum part, the bass guitar part, and so on. The energy consumption limit is set to 50%. With the help of the Ultimate Vocal Remover 5 version, I launched the procedure of dividing the music file into the drum part, the bass guitar, vocal part, the guitar, and the piano. Let's look at the time of execution of the process with this limitation. I use model V4HTD-MUX6 to divide the files. The total processing time is 1 minute 30 seconds. Now we remove the energy consumption limit. In other words, we set it to 100%. We run our process again. In a good way, we should evaluate the time of running inference. But since we evaluate all time, this from the point of view of applied tasks, I will compare the total time. The difference is not very big, 1 minute 22 seconds total time. Thus, for the task of dividing the music files, setting the limit to 50% is also a small hindrance. Now let's see how the speed of generation pictures change with Neural Networks model Flux.1 in the ComfyUI environment. We set the energy consumption limit. ComfyUI is already running. I made the simplest workflow. I use the Flux.1 Shnell Q2K model in the GGUF format. Also, I use VIA and clip encoder models. I will test the resolution of the picture 512 pixels. We run the loading of the VIA model. Let's see how much the Python process consumes RAM. The text encoder model are running. It's loaded into the RAM and video memory. The consumption of video memory increases, almost 4 gigabytes of video memory is occupied. The RAM is about 9 gigabytes, the K-sampler node is running. We are interested in the time of one iteration of the K-sampler node. Since we use the Shnell model, there will be only 4 iterations in total, and we are interested in the time of one iteration. In the process of generation of the picture, the K-sampler node is most time-consuming of the entire process. The Flux.1 Shnell Q2K model is loaded into the video memory. Almost 5 gigabytes of video memory is occupied. And the process of generation of the picture is going on. The first step is to look at the time for watching the first iteration was done. The second iteration has been completed. The time is 18 seconds per iteration. So we have waited for all 4 iterations. The picture is ready. The total time of execution is approximately 172 seconds. The request has been completed. Let's correct the request a little, it is not so boring, and we will remove the video speed limiter. After that we will start the generation again and see how much time will be spent on each iteration. I put 100% limit, that is in fact its absence. And I start again. The generation process in the K-sampler does not depend on other nodes. Therefore, the experiment will be quite indicative in terms of how much faster or slower it will work. Let's look at the generation of the pictures when the video card has no energy consumption. Now the Flux model is loading into the video memory. 5 gigabytes of video memory is occupied. And the generation process is already going on. The first iteration is going on. And we are interested in how much time is now. (21 seconds) is more than it was for some reason. Also, the power limit was removed. I will have to repeat the experiment again. (132 seconds is the total time, but this is clear because there was a cache of models. The total time is less, but the time of each step is greater. Why is it greater? Now we will figure out. Again I set the limit to 50%. Again I run the generation with the same parameters. The first step has already started. The model is already on the video card. 5 gigabytes of video memory is occupied. 22 seconds per iteration with limited power. Now we will remove the limit again and run the process again. Thus we will get some average values that we will compare. Four steps completed. The picture turned out. Now we will remove the power limit. Run generation with the same parameters. TV on the top of the mountain. "20 seconds per iteration. Without power limit, 20 seconds. With the power limit turned on. In general, it is already clear that the power limit is not high hindrance for the task of the generation pictures. The time difference is insignificant. Thus, I put the power limit on a constant basis. I remove the second power supplier from my computer, which, as it seems to me, has not been working stably lately. After all, it was connected only to the video accelerator, in connection with what the 5V power supply channel was loaded on a resistor, which apparently is not enough for stable operation of the power supplier.